2024, the James Webb Space Telescope pointed at a patch of empty space and saw something impossible. Galaxies. Fully formed galaxies. Billions of years before they should exist. And nobody can explain it. To understand what JWST found, you need to see what we couldn't see before. On the left, Hubble. On the right, Webb. Same patch of sky. But Webb sees further back in time, and what it saw changes everything. Here's how we know these galaxies are impossibly old. As the universe expands, light from distant objects stretches. This stretching shifts light toward the red end of the spectrum, called redshift. The more redshift, the further away, and the further back in time we're looking. These galaxies have extreme redshift. They're 13.5 billion years old, just 300 million years after the Big Bang. Let's look at the specific galaxies. Glass Z13, 13.5 billion years old, only 300 million years after the Big Bang. And it's not small. It's 1,600 light years across, with 1 billion times the mass of our sun. Then there's Glass Z11, almost as old. But here's the shocking part. It's as massive as the Milky Way, a fully formed spiral galaxy in what should be the infant universe. Here's why this is impossible. The Big Bang happened 13.8 billion years ago. We expected to see the first large galaxies forming around 500 million to 1 billion years later. That's how long it should take. But JWST found massive galaxies at just 300 million years. They formed too fast, way too fast. These ancient galaxies don't look like babies. They look like the Milky Way, mature, organized, fully formed, as if they skipped childhood entirely. Let's walk through how galaxies are supposed to form. First, dark matter clumps together. That takes tens of millions of years. Then gas falls into those gravity wells and compresses, another 50 million years. Eventually, the gas gets hot and dense enough to ignite the first stars, at 100 million years. Those massive stars burn fast and explode as supernovae, spreading heavy elements, 200 million years. Then, new stars form from that enriched material. And finally, after all of that, you get an organized galaxy structure. Total time? At least 500 million years, often 1 billion or more. But these JWST galaxies completed all of this in just 300 million years. They didn't have enough time. It's like finding a 25-year-old person with 50 years of life experience. The math doesn't add up. This discovery challenges 3 fundamental theories. First, dark matter formation. Our models say dark matter should clump slowly, but these galaxies suggest it clumped much faster. Second, first star formation. We thought the first stars were a certain mass and lived a certain amount of time. But to create these galaxies, they must have been even more massive and burned even faster. Third, galaxy mergers. We thought big galaxies form from small galaxies merging over billions of years. But there wasn't time for that. These galaxies assembled impossibly quickly. 1 telescope, 2 years of data, and decades of cosmology models are now being questioned. So if our models are wrong, what actually happened in those first 300 million years? Scientists have 4 main theories. Let's break them down. Theory 1. Dark matter clumped faster than our models predict. Maybe dark matter is more clumpy by nature. Maybe it responds to gravity more strongly in dense early universe conditions. If dark matter forms structures 3 to 5 times faster, galaxies could form earlier. Theory 2. The first stars were even more massive than we thought. Instead of 100 or 300 times the sun's mass, what if they were 1,000 times more massive? These supermassive stars would burn incredibly bright and die in just 1 million or 2 years, not tens of millions. They'd speed through their life cycle, create heavy elements, and explode. Galaxies could form much faster if the first generation of stars were these extreme giants. Theory 3. What if we're wrong about the universe's age? We think it's 13.8 billion years old, but that's based on measurements that have uncertainties. What if it's actually 14.5 billion years old, or older? That extra 700 million years would give galaxies more time to form. It wouldn't solve the problem entirely, but it would make these early galaxies less impossible. And theory 4, the most radical idea. What if physics itself worked differently in the early universe? What if gravity was stronger? What if fundamental constants were different values? As the universe expanded and cooled, maybe the rules of physics changed, settled into the values we measure today. If that's true, early galaxies could have formed under completely different rules. Rules we've never observed because we can't travel back in time. So which theory is correct? Honestly, we don't know. It might be one of these. It might be a combination, or it might be something we haven't thought of yet. And these early galaxies aren't the only impossible thing JWST has found. There are exoplanet atmospheres with chemistry that shouldn't exist, supermassive black holes that formed too quickly, stars that appear older than the universe. JWST is breaking our models left and right. Take the Hubble tension. We can measure how fast the universe is expanding in two different ways, and they give us two different answers. A 9% difference. That might not sound like much, but in physics, when two precise measurements don't agree, it means something fundamental is wrong, either with our instruments or with our understanding of the universe itself. And that's where we are. Conferences filled with astrophysicists debating competing theories, papers being published every month with new hypotheses, models being revised, textbooks being rewritten. So what does all of this mean? We thought we had the universe mostly figured out. We had a timeline. We knew when galaxies formed, how they formed, why they formed. And then JWST looked deeper than we ever had before and showed us we were wrong. And that's good. That's how science works. The Hubble Space Telescope broke our models in the 1990s. The discovery that the universe is accelerating broke them again in 1998. Every major telescope, every major discovery has forced us to revise what we thought we knew. JWST is doing the exact same thing. It's not a crisis, it's progress. And here's the beautiful, terrifying thing. We're only 2 or 3 years into JWST's mission. It's designed to last 20 years or more. These impossible galaxies, they're just the beginning. We thought we understood the universe's story. We thought we knew how galaxies formed, when they formed, why they formed. The James Webb Telescope, in just 2 years of operation, has shown us we were wrong. And the most exciting part? We don't know what we'll find next. What other impossible things are waiting out there in the dark, just beyond the edge of what we can see?